In this section we're going to talk about inverses and their derivatives. So before we talk about the derivatives part, let's first review inverses. We're given that these are inverses and we want to verify that's true. F of x and we have the inverse. Recall from pre-calculus that this is how you verify that these two functions are inverses. You're going to do composition functions, so we're putting the inverse into the original one, and the original one we're going to put into the inverse. When you simplify all that, you should get x, and you have to show both of these are going to be true in order to verify it. So let's go into that with these two examples. So this is saying that we're going to put the inverse into the original one. The inverse is this right here, 1/2 x plus 1/2. So I'm going to put 1/2 x plus 1/2 inside in place of the notation I have for the inverse. I want to simplify it, and I should be getting x as the answer. This is telling us that we're going to take the original function f of x, remove the x, replace it with 1/2 x plus 1/2. So the template itself that we're using here is going to be 2x minus 1. So originally it was 2x minus 1. We took out the x. We have space there. Space gets replaced with 1/2 x plus 1/2. Now we're going to simplify that. You can multiply through by 2. You get 2 over 2, which is a 1x, and then you get plus 1, but then you have a minus 1 afterwards, and then that's going to end up giving you an x. So we've shown now that we did do this first part of it, and we got x as the answer when we simplify. Now we have to show it's true for this one. So this one, we're starting with the inverse, and inside the inverse we're going to put f of x. I'm going to replace the f of x with the formula 2x minus 1. Okay, so I put that in there, and then again I'm going to simplify it. I'm going to use the inverse as the template. Inverse is this one. That's 1/2. Instead of x, I'm going to put a space there, plus 1/2. That's the template I'm using. X gets replaced with what's inside the parentheses, 2x minus 1, and then I'm going to multiply this through and simplify. 1/2 times 2 is again a 1x. Then I get minus 1/2 plus 1/2, and those are going to cancel. That's going to leave you with x also. So now we've shown both cases are true. We did the compositions, we simplified it, we got x for both. So that's the verification. We know for sure these are inverses. So what we're going to talk about next is what's the importance of the x? Why does the x come out? And you'll see why that's true when we talk about the graph next. Now that we've verified that these are inverses, we're going to graph these two, and since we got x as the answer, I'm also going to graph that one as well. We want to do all this on the same axis, which means that they want you to put all these on the same graph. Let's start with the first one, 2x minus 1. Minus 1 is the y-intercept. Slope is 2 over 1, so from this point we're going to go up 2 over 1, and we can do that again if we want to, up 2 over 1. We have 3 points, so we can just connect these with a line, and that right there is going to be your f of x. Next, let's graph 1/2 x plus 1/2. Okay, so 1/2 is right here. Okay, that's your y-intercept, and from there we're going to go up 1 over 2. So up 1 over 2, we'll get this dot right there, and we have these 3 in a row there that it's going to go through. So this is the inverse. But then it also asks us to plot y equals x. Y equals x, I'm going to show that as a dotted line. So that is going to be a slope of 1, goes through the origin. So it's going to go through 1, 1, 2, 2, 3, 3, and so forth. And that's going to be this one, y equals x. Now the importance of the x, what it means, the significance of that is the y equal x is actually going to be a fold line. We can take this part of the graph and we can fold it over on top of the other one, so that way this lines up on top of the other one there. So that's basically what x always does. Whenever you have inverses, that's what happens. You're always going to have this fold line happening on that one. Also, what you're going to see happening here is this point right here, let's label that. This point was 2, 3 on it. If we were to find another point on this line right here, this would actually be the point 3, 2. So another thing that happens with this is that fold line, it reverses the x and the y coordinates. So you have 2, 3, and then you have 3, 2. So the x and the y are switched. We're going to come back to this idea later, because when we talk about how to find an inverse algebraically, we'll come back to this idea where we have to switch the x and the y.